Our last section in this calculus 2 part here is to do with the point of inflection. So the point of inflection is a specific point in our graph over here. So the point of inflection is the point where we stop decreasing and we start increasing. So here in this case, what we have is we have our slope here, and the slope is going from -1, -2, -3. But at a certain stage we have to stop because we need to start coming back up towards 0. So it's at that point there where our slopes are no longer decreasing and no longer increasing. They're stopped so they can go from decreasing into increasing, or vice versa, from increasing into decreasing. So if the graph looked like this, our point of inflection would be around here, and our slopes would be something along the lines of there's a 0, there's a 0. Here I have a slope of 1, 2. At that point there's my slope of 3, but now I have to start going back down so I can go towards 0. So you can have it with an increasing or in a decreasing graph. So with the second differentiate, with a point of inflection, what we're going to use is the second differentiate, because what we're looking for here is the rate of change of the slopes. So here at this point, my slopes stop decreasing and start to increase again. So they have to, at one stage, stop. So it means that the second differentiate will equal 0. There is no change in what the slope number is doing, what the actual number for the slope is doing. And that's where we end up getting this little bit, down here. Our second differentiate equals 0. So once they mention a slope, a point of inflection, it's just our second differentiate and it equals to 0. So now let's go and take a little look at a question on how to do it. So here is our question here, and we have our coordinate at the top here. There's our slope is 0. Here again is our slope is 0. It's going to be somewhere around here. Okay, so the point of inflection will be somewhere, it'll be halfway between the maximum and the minimum point. And we're looking to find that exact point there. We know at the top our first differentiate equals 0. It's at this stage here we're talking about our second differentiate equals 0, because we're looking at the slope numbers. The slope numbers going 0, -1, -2, -3, -2, -1, 0. It's this point here where the slope stop getting smaller and start getting bigger. So if we were asked to find the point of inflection, and remember it's a point, so if it's a point, that means that once we have the x value, we have to go find the y value. What we're going to do is we're going to say our second differentiate equals 0. So I'm going to get my first differentiate from my function up here at the top. My first differentiate is going to be 3x squared minus 12x plus 9. My second differentiate is going to be 6x minus 12. So I'm now looking for my second differentiate to equal to 0. So 6x minus 12 equals 0, and I'm just solving like normal. And I'm getting x to be 2. So that's my coordinate, that's my x coordinate. But don't forget, we need to go find our y coordinate. So how do we find our y coordinate? We sub it back into the original. So I'll just move this up a tiny little bit. So here, I'm going to find my f of x is x cubed minus 6x squared and 9x. I'm finding f of 2. So I'll have 2 to the power 3 minus 6 times 2 squared plus 9 times 2. When I check the calculator, I'm getting the number 2. So that is where x is 2 and y is 2. And if we check on our graph, that is that coordinate there. It's the point 2, 2. It's the point of inflection halfway between the two the 2 points, turning points, maximum point and minimum point.